Okay, so let's take a look here. Let's take a look at another type of problem involving some transformations on a rational function. Okay, so what are we dealing with? We're dealing with our base function here. F at x is 1 over x. So it's undergoing a vertical stretch by a factor of a third. We have a reflection in the x-axis. And we have a translation 1 unit right, 1 unit to the right, and 2 units upward. And another piece that's important, this new graph, it's going to be called h of x. And so the question is asking a couple things. It's state the equation of the transformed graph, so state the equation of h of x, and sketch the graph on the coordinate plane. So let's start chipping away at this. How I like to tackle some of these problems here is I'm just going to start by writing out my mapping notation. So our points P, x1, y1, they're going to be mapped, and they're going to be mapped at points P prime. And then let's just see how each point is changing in terms of these transformations. So the first piece here was this vertical stretch by a factor of a third. So that is taking all of our y values, or y1 values, multiplying them by a third. Okay, the next piece is we have this reflection in the x-axis. That is a vertical reflection, so that's actually going to be a negative third. We're going 1 right and 2 up. So 2 up will be added to our y values, and then we're going 1 to the right, so that's going to be our x1 values are going to be there's going to be 1 added to those values. Okay, so another important piece when I'm looking at this mapping notation, this is all in terms of our original points x1. It is really important, especially when we're building function notations and equations, to understand, okay, these are equal to x2, those x values, or our new x values, and this is equal to y2. And why that's important is because we want to get a equation in terms of x2 and y2. So how we can do that to start, let's look at the x parameters here. So what I said was x1 for our original points plus 1, that's going to yield our x2 values. Now let's get this in terms of x1. Why this is important, so I'm going to subtract 1 to the other side here. Why this is important is now I have an expression that involves x2. So we've kind of undid what happened to x1, and now we have some expression here in terms of x2, and this is actually going to be our new input on the h of x function. Okay, so let's just keep that in the back burner. Okay, the next thing we can take a look at is the second piece with the y values. Well, we can say, well, our new y values are equal to negative 1/3 y1 plus 2. I'm just going to rewrite this a smidge. Okay, so y2, well, that's essentially our new function h of x. That's our new function h of x with our new input values, our new x values. That's going to be equal to negative 1/3. Now y1, well, that's our function f, our original function, with our input values of x1. Okay, so and then we're going to tack on a plus 2. So what we can do now is simply just pop into here what we did over here. So we have our function h of x is equal to negative 1/3 f, and I'm not going to write these subscripts here, but that's the same thing as saying x minus 1, and then we're tacking on a plus 2. Again, I just removed those subscripts, but I could have put a 2 there and a 2 here, and then we have everything in terms of our new inputs x2. Okay, so how do we build an equation based off of this? It's actually quite simple. All we're doing is, if you take a look and kind of break down what's happening here, well, what we're doing here is this is our base function. It's kind of buried in there. But what we're doing is we're changing the inputs to x minus 1. We're going to take that and multiply it by negative 1/3, and then we're going to tack on a 2 at the end. So what does that look like? Well, we're going to go, like I said, negative 1/3 And we're going to take our base function, 1 over x, but just bear with me for a sec, it's not 1 over x. We're changing that input to x minus 1, actually, just like that. And then we have this plus 2 at the end. And then we can clean this up just a little bit. I'm just going to clean this up. So this is a similar way to write this. It might be a little bit more useful and applicable. So this equation here, we can actually pull some really important pieces off of it. To start, I want to look at this value. This is a k value of 2. Well, that means we've shifted this thing 2 units up. So what does that mean in terms of the graph? Well, this horizontal asymptote here that is originally on the x-axis is going 2 units up. So it's going to be moved to here. So this was my horizontal asymptote. That's going to be at y is equal to 2. So this is really important because this tells us where our horizontal asymptote has now shifted to. The next piece that I really like is this piece here, this minus 1. Well, this actually means we've shifted 1 unit to the right. And what's going to happen is you're going to notice our vertical asymptote is going to be shifted 1 unit to the right based off of our base function, which was originally 1 over x. So the vertical asymptote, which is currently on the y-axis, will be right here. So right there. So the horizontal, this is the vertical asymptote at x equals 1. All right, so what else can we look at in terms of this equation? Well, if I'm looking at the equation here, you see this negative symbol? Well, that negative symbol is like a negative a value. We have a negative a value here, which means we have a vertical reflection in this graph. So what that tells us, a vertical reflection, if you just take a look here, the original 1 over root x graph sat here. I don't know, just sketches here and here. Just bear with me. Let me change the color. Let's get it to pop a little bit. So the original root x function would have sat here and maybe just like that. But it was reflected. It was vertically reflected. So where it's going to exist now is something like this. Let's get our pen out. It's going to look like that. Or up here. That's what the reflection is going to do to this thing. I want to maybe just be a little bit more precise with some of the values. So let's let's figure out some of the intercepts on this graph. So I'm just going to be a little bit more precise. So I'm going to erase these. So let's take this function here. Let's figure out the x and y intercept. So the x-intercept of this thing, well, what we're going to do is make y is equal to 0. And then we're going to solve for the x value. All right, so we're going to subtract 2. So we have it written something like that. We can divide both sides by -1. So we don't have a negative value on there anymore. Okay, we can rewrite this a little bit differently. We can rewrite this in terms of getting that x out of the denominator, but this is an equivalent way to write that. And then from there, we can divide both sides by 3. So we're going to have x minus 1 equals 1 over 6. And then I'm going to add 1. So it's going to be 1 over 6 plus 1, which is 7 over 6. So our x-intercept is at 7, 6, and 0. So let's plot that point. So it's like 1 and 1/6 and a y value of 0. So that's going to be 1 and 1/6. So that's like right here. Okay, we got the x-intercept here. Let's complete the y-intercept next. Let's just do that just below. All right, so when we're evaluating our y-intercept, we take our function here, in this case is h of x, and we're going to input a 0 for our x value. So it's going to be negative 1 over 3, 0 minus 1 plus 2. So what do we have? It's going to be negative 1 over negative 3. So it's going to be 1/3 plus 2. That's going to be 1/3 plus 6 over 3, and which will be 7 over 3 with an x value of 0. So there is our y-intercept. It's 0 and 2 and 1/3. So let's plot that. So 2 and 1, so like right here. Okay, so now we can actually probably do a fair sketch of this thing. So we know that this thing is going to approach this vertical asymptote, and it's going to kind of roll like that. And then the same thing on the other side. It's going to approach this asymptote, and it's going to get closer and closer to that horizontal asymptote there. And we would just define that as h of x. Okay, so this is some good practice here, sketching a transformed base graph and then writing the equation.